Hello friends, welcome to my channel, a channel for learning simple coding. If you find this video to be helpful, please like, share and subscribe my channel. In this video, we are going to learn how we can get congruency in our application using Goroutines in Go language. I have made few videos on Goroutines also, but in this video especially I am talking about congruency, and in next video I will talk about the congruency control, and so many concepts are linked with this concept also. So let us start. What do you mean by congruency and how we can achieve it in Go language by using Goroutines? So for understanding the congruency, let me start first of all MS Paint to understand it. Suppose we have a one process like this. I have a process P1. Remember to understand this. So this process have some task to perform. Okay. So I say this process will perform a task. So I say this process want to perform a task like this. So this task can be achieved from starting from a line 1 to line n, the end number. Understand this? So at the end we will have a result, means this process will perform some task one by one because we have no non-congruency. Then start from first line to end line, and at the last we will have a result, means this at the last we will have a result. This is result we have. So this is a normal way of execution of your program. But if we are performing a congruency, so what we do, we just convert this program into small task. Remember that we just convert this task, big task, to small task. We say task 1.1, then task 1.2, then task 1.3, means the same task. You can say this is one task, task 1, that is 1.1, 1.2, 1.3. So this task is converted into subtask like this, remember. Then these tasks will execute any number of time inside this memory space. We can say it's a memory space. We may say it is thread, we may say it is your coroutines. The order of execution may be anything, maybe task 1.1 first, then task 1.3, then task 1.2. Remember, but we will achieve a same result. Remember, we will achieve a same result which we were getting from here. So we will perform a task in a order here in memory space like this. It may be any order, it may be this order, it may be this order, task 1.3, then task 1.2, then task 1.1. doesn't mean anything, but you will have a same result every time. It will perform a task. Ordering may be anything, but you will perform a task. So that is called the congruency, and this we have to achieve, means we have to divide this task into small tasks, and they will take a memory space somewhere else, and they will execute together and will give the same result which we are without a thread or without a coroutines. So that we are going to implement. So let's understand here a program. We have a main function implementation here. Then I define one more function and I say this function check URL connection like this, and we have URL of string type, and here we use response and error for http dot. We have the http dot get, and here we pass URL, and I save this here. Then we may import package also. Import, we may say fmt. Then we may have one more import. We may have net/http. This may have. Now we can check error. If error not equal to nil, then we say panic and we print the error. If no error at all, then we say fmt dot print f. Then we put here that status, that we will display status here. So we say %d. Then we say URL %s/n, and here we print response dot status code, and then we should display URL also. So like this we have this function, and now in this function we check number of argument. If os dot args greater than less than 2, and we have to calculate the length of this like this, and here we can display that log dot fatal error fatal, and here we print use, I say less than 2, use like go run main, then URL 1, URL 2, URL 3, and URL n. Like this we have to use. Then if everything is okay, then I run a for loop, and here I take URL, one URL from this range, I say os.args, and I run it from 1 to all like this, and here I call this function, that is check URL connection, and here I will put URL and save this. So we have this error we have this one. So OS is undefined, it's saying OS is undefined, so we have to declare this package also OS, save it. Now this URL is undefined, so why? Because it's taking a range, index number, we need a value, save it. So we have this. Now we try to run and check and test the congruency also. So first of all, I need to change to the package in which I am trying to run it. So CLS. Now I need these all URL that I am going to test, and remember that I am going to check the congruency. So I say go run main and I paste this URL here, press enter. So package is not in Goroutine, so we say main.go because its file name, go run main.go, press enter, and we have to change it to HTTPS also because it's a URL. So we have to change to HTTPS like this and save it. Once again I just CLS and try to execute it once again, and you will see that one by one it's checking the status of this URL and it displaying a result. See, one by one. Remember that I explain you that it's a one task only, but this task is performing a testing of these URL 6 or 7 8 URL. Once again I try to run it, and you will see that if I increase the quantity of URL, then it will take long time. See that ordering is same here because it's a one task, it performing by this application without using any Goroutines, without using any congruencies. Now to perform a congruency in your application, just we need to put go here. Remember that we need to put go here, and in Go language automatically this function will become or convert into Goroutines. What is Goroutine? You can check in my previous video also. I have explained with proper example. In this video I am just telling you that put a go here in this function, and this function will convert into a congruency application. If I run it, it would not display any output this time. Why? Because it's a now this time we have a two Goroutines, one which I convert here, one is a main by default. But problem is here that whenever we start this Goroutine, this main close. That's why it's not able to put here result. So we have to hold this for a time being. So I say here sleep, and then I here give the time in second. Remember that 1 second I am giving a time. So it will tell me to give the time as a package. So I take time also here. Now remember that I try to run it, same program I am running, and it is now congruency is achieved. You see it congruency achieved. I given the go.google.com first, but it's a github.com and it's only 4 URL coming, not showing all the URL because I hold this output for a 1 second only. So I multiply for 5 seconds. Remember that I multiply for 5 seconds. Again I just run it and I will have a same result. You see output, but it will take for 5 seconds, then it will finish. So by this sleep method I am not able to control the congruency of this application. I make it congruent, but I am not able to control the congruency, that whenever this application, this function will finish a task, then automatically this application should close, or if it take long time it may take, if it takes short time it may close before the time. But I am giving here 5 seconds, so this 5 seconds is too long for this application, but if I give 2 seconds it's too less. So I am not able to judge when this function will complete a task. That's why we use wait group in Go language for achieving a congruency controls. We can control as we want. So I will show you how you can use this wait group to achieve the congruency controls in Go language. But here you should understand that I hold this for 5 seconds. So within a 5 second this application perform their task. But remember that here once again I try to execute it, and you see the output here, the GitHub first, then Twitter, then Google, then YouTube. I am getting a same result. Same result means the output is same, that everything is checked, all URL is checked, but order is not maintained. I explain you there, the order is not maintained, but task is same. We are checking a result. We want to check the status of each and every URL. The same is here. But I remove, if I remove this here from here and I save it and run once again, you will see that you will have one by one, then Google, then Facebook, then Twitter, means order will be maintained. Last is a yahoo.com because I given Yahoo. See, one by one this task is performing, but when I give here a go, so this program is convert into small task. This is convert into small task. One task is divided into small task. That means the program run congruently, and it checking each and every URL, checking the status and displaying here, and taking 5 seconds of time. But this time is too long for this. Maybe I give here 2 and I run once again. So 2 is less. If I give 3 and 4, so it's just like a testing. But maybe that this URL is not checking by some internet problem or some other issue. So this program may crash because of the time issue. And it must to maintain the congruency control also if you are using a Goroutines here. So how you can maintain this, we will see in next video for using a weight group, how you can use weight group and how you can achieve such kind of congruency control in Go language. We will see in next video. Thank you for watching this video. I think you understand something from this video. If you really understand anything from this video, please like, share and subscribe my channel. Thank you for watching this video.